Support for Central Florida Public Media comes from the Embry-Riddle Aeronautical University Worldwide Campus, providing students from all 50 states and 119 countries with innovative education and opportunities for success. More at erau.edu/ww.
What's going on in our skies and how we're studying space mysteries with a new telescope. You are listening to Are We There Yet?, the radio show exploring space exploration. Hi, I'm Brendan Byrne. From meteors streaming across the night sky to a solar eclipse, there's a lot happening in our skies this week.
They're going to streak across the entire sky. So really the best thing to do is just lay back, just take in the whole sky.
We'll speak with Lohman Planetarium's Seth Mayo about what's happening in the world of astronomy and how we can see some of these cosmic events ourselves. Then we'll turn to cosmic events further out in our galaxy, things like dark matter and dark energy, and how the Nancy Grace Roman Space Telescope hopes to study all of these cosmic mysteries.
It's all these 1 in a million things that we're going to be able to see with Roman that really excites me.
We'll hear from NASA's Jeremy Perkins about what we can expect from its planned launch later this month and the first few observations of Roman in space. That's ahead on Are We There Yet? It's a week of cosmic events. On Wednesday, August 12th, some people will see our sun disappear and suddenly be in darkness. Some areas like parts of Europe, the North Atlantic, and North America will be able to see this solar eclipse as the moon moves between the Earth and the sun. But if you can't see the eclipse, there's other events happening in the sky this week that you can see, like planets aligning and meteor showers. Here to talk more about what to look for is Seth Mayo. He's the curator of science and director of the Lohman Planetarium in Daytona Beach. Seth, welcome back to the show.
Hey, Brendan, it's great to be back on the show. Thanks.
In preparing for this interview, I realized that my brain always mixes up solar eclipse and lunar eclipse. What are we going to be seeing, and how can I remember which one is which?
For either scenario, solar or lunar, it's when the Earth, moon, and sun line up in a straight line. In astronomy, we have a really fun word for it. It's called a syzygy.
A syzygy?
That's S-Y-Z-Y-G-Y. It's a great word. It's one of my favorites. So 3 bodies lining up.
Syzygy. All right.
Syzygy, yes. Fun word. So that's when 3 of those objects, Earth, moon, and sun, line up in a straight line. For a solar eclipse, that is when the moon is in between the Earth and the sun, and the moon blocks the sun, right? So for a solar eclipse, the sun is blocked in that instance. For a lunar eclipse, the moon actually passes into Earth's shadow and turns that kind of bloody red color. The one that's coming soonest, on August 12th, is a total solar eclipse. And this one is happening over parts of Western Europe, North Atlantic, and very northern parts of North America. So if you're along this very specific path called the path of totality, and that's where the moon is completely blocking the sun, and this is happening for much of their evening time in that part of the world, then all of a sudden the sun is blotted out for a little over 2 minutes if you're, depending on where you are in the path of totality. It's about a 180-mile wide path. And if you're in that path, all of a sudden your day turns to night. Crickets start chirping, the birds start to quiet down, and even the temperature goes down. It's a really amazing, kind of a life-changing thing to be in. So you have to be along that specific path that goes through parts of Greenland and Iceland, North Atlantic, and then northern parts of Spain. But if you're in areas around it, you could have a partial solar eclipse. Now, the only place you can safely view this with your naked eyes if you're in the path of totality for that brief moment. But anytime around that eclipse, or if you're in partial eclipse, you have to have solar glasses, approved solar glasses, or some specialized equipment for cameras or telescopes. Parts of North America, very northern areas, New England area, Canada will have a partial eclipse for this coming up on August 12th. But again, if you're in northern Spain, you're in Greenland and Iceland, it's an amazing sight to see. Now, I have a trivia question for you, Brennan. Do you know the last 4 people on Earth, or at least from Earth, that got to see a total solar eclipse?
I do know this. It
All
is
right.
the crew of Artemis II, was it not?
Yes. So I think that's kind of a fun fact. I know you would know it, of course, but it's a fun fact that the last people for humanity that represent humanity were the Artemis II crew when they kind of put themselves, the spacecraft was on a trajectory to go behind the moon. And instead of a 2.5-minute eclipse, they got a more than 50-minute, almost an hour-long eclipse, right? And of course, we saw the great photos, and they got to see meteor strikes on the surface of the moon. And then what's also interesting about eclipses is they come in pairs usually, right? So if you have one eclipse, usually before or after, 2 weeks before or after, you have a lunar eclipse. So at the end of August, August 27th, 28th, we have a partial lunar eclipse when the moon passes partially into Earth's shadow. For parts, actually a big chunk of the United States and North America, they get a really nice, and we get a very nice partial eclipse. About 86% of the moon will be in Earth's shadow. And so you get that really nice deep red color, but with still a sliver of that reflected light from the sun reflecting off the moon to your eyes. And so you can look at that safely. There's no special equipment you need for that. That's just good with your naked eyes. More towards the late evening, at least on East Coast time when that occurs.
Seth, do you know I've never seen a total solar eclipse yet? And I think it's because I'm waiting for you and I to be able to go and see it from space. Right? Why don't we just do that?
Life-changing. I saw the one back in 2017. And a really good one to look forward to. We're going to plan our trip now. 2045 is a great, so we'll plan that one for 2045. There's one coming across the United States, and in Florida, it's going right through Central Florida.
Look at that.
So we're a little older by then, but we'll be talking about the 2045 amazing eclipse that comes right through Florida. That'll be great.
I'm hoping you and I will be retired by then, and we'll come out of retirement to do this podcast.
We'll be in our rocking chairs on another version of Are We There Yet? That'd be
back
amazing.
In my day, we had to.
Yeah, that'd be awesome.
All right, so I'm not going to get a chance to see this one, but there's some other things that are happening in the night sky that we will get to see, right? We got a meteor shower coming up, don't we?
Yes, and also near the same time, too, of this total solar eclipse. So a lot going on in mid-August. So, and this is always happening in August, the Perseid meteor shower that occurs kind of the morning or really late night, August 12th, early morning, August 13th is the peak of the shower. It always happens around this time of year, and that's because Earth is passing through the debris trail of comet 109P Swift-Tuttle. And this comet goes around the sun every 133 years, leaves behind a debris trail, and we're always smacking into it in August. And really, it is one of the best meteor showers you can see all year round, especially this one. This is the one that people really need to stay up late for or get up early for because it's near a new moon, right? We don't have the reflected light from the moon because, again, for a solar eclipse to happen, you have to have a new moon phase, and that happens on August 12th. We have this new moon, which means it's much darker in the sky. We have the best conditions for a meteor shower. Really the best time, I know this is not convenient for most folks, but like the 2 a.m. to 4 a.m. time period. And that's because the Earth is kind of towards it, kind of going into it. And so we're getting a more direct hit by the meteors. Nothing to be alarmed by, nothing to worry about. These are little, tiny little microscopic pieces entering the atmosphere at thousands of miles per hour. It's just a pretty show. And when this particular meteor shower is good, you could see up to 50 to 100 meteors per hour. You don't need to look in any particular area. It is called the Perseid meteor shower because it radiates out of a point near the constellation Perseus, which rises out of kind of the northeastern sky. It's more of a fall constellation, so the later you stay up, the higher it gets in the sky at this time of year while we're still in summertime. That's just where they come from. They're going to streak across the entire sky. So really the best thing to do is just lay back, just take in the whole sky and let your eyes adjust. 5-10 minutes if you're in a dark enough location and just kind of wait for it to happen. Some people, of course, will take pictures. I'll be doing that, taking long exposure photos, trying to capture something for our planetarium. But you don't need anything. You just need to sit back, have some patience, and just wait for what unfolds. And you're going to see so many things. You're going to see stars, constellations, especially if it's clear, and maybe a satellite or two. So there'll be other things moving across, but the meteors will shoot very quickly across the sky. So you will know the difference when you see one.
I will do that. I'll just try to stay up. I may fall asleep if I'm looking up at the dark sky for too long, right?
That's okay, too.
You're listening to Are We There Yet? The radio show exploring space exploration. I'm Brendan Byrne. We're speaking with Seth Mayo, the curator of science and the director of the Lohman Planetarium, about some of the things we can see in our skies in the world of astronomy. All right, we got another celestial show coming up. Venus is going to be high in the sky, right? Tell us about what we can see there.
Venus, you might have already noticed if you look in the evening after sunset, you see this really bright object. It looks like a super bright star. Some people like to call it the evening star when it's out in the evening, and that is the planet Venus, as you're mentioning. The brightest planet you can see from Earth. I'm sure most listeners have seen it, know about it, maybe even just keep track of it. And it's going to reach its highest position in the sky also in mid-August. It's called greatest elongation. And so that's when it's farthest from the sun, high up again in the west after sunset. And again, don't need anything special to see it because of how bright it is. It is the brightest object in the sky behind the moon. So it really shines. And it's bright because of that thick carbon dioxide atmosphere reflects a lot of light. Because it has that atmosphere, it has temperatures that get up to 900 degrees Fahrenheit. So you're looking at a really kind of scary place, but it's really beautiful in the sky, very high up. Again, you don't need anything special other than just a clear sky. It'll be about 45 degrees up from the sun. So you got a lot of time to see it in the evening when it's at this highest position. So highest in mid-August, but you'll still have a lot of time before it starts to sink back towards the sun through the rest of the month.
All right, I've already forgotten the fun word that you told me to learn at the beginning. Syzygy.
Or the lineup of objects, yeah.
Okay, and I only bring it up because we're going to say what is now my second favorite word in astronomy, which is conjunction. And there is a conjunction happening. And
Yes,
this is
there
when
is.
celestial bodies line up, right?
This is another mid-August event. I think, I don't know if the universe is just trying to cram everything in mid-August.
And back to school. And go back to school, right?
And back to school. Yeah, a lot going on here. So anyway, so a conjunction is when two or more celestial objects get really close in the sky. Most of the time, they're not actually close. It's just sort of a vantage point, viewpoint thing from Earth, and they can look really interesting. And in this case, in the morning of like August 14th, August 15th, early in the morning, actually, there's a very specific moment that's the best, and that's the morning of August 15th. That's when Mercury and Jupiter get very close. Now, instead of the evening, you need to be out in the early morning. So you got to wake up early, look just above the setting sun. Really good time is right before twilight hits, so in the 4 to 5 a.m. time frame. So right now, 6:51 or about that time is when the sun actually rises. So you need to get out maybe an hour before that if you can, and look at this. These two objects are going to look like stars that are not twinkling and are really close. And Mercury is one, which is the smallest planet in the solar system. And then you have Jupiter right next to it, and Jupiter is going to be brighter. So that's how you know the difference. And they're not close again. So Mercury is the closest planet to the sun, and again, the smallest. And at that point, it'll be about 110 million miles from Earth. And then Jupiter will be more than 580 million miles from the sun, or from us, I should say. So they're just lining up in just the right way for them to look close. And these conjunctions are just fun to look at, to enjoy multiple things at once. Saturn will be higher in the sky as well, and other planets, again, Venus in the evening. So there's a lot of planets to enjoy right now. Just depends on what time you go out and look.
Finally, Seth, where are some places or maybe some apps that you would recommend for people to download or utilize to help kind of see some of these things, keep track of what's going on in the sky?
Yeah, that's an excellent question. I get that a lot too, and I always enjoy talking about it. So one of the apps or programs I love to use is one called Stellarium, and you can download it for free on your computer. A lot of folks may recognize Stellarium. They'll also have app versions, iOS and Android phones and all those type of devices. There's different versions, of course, like many apps, and it will allow you to understand what you can see in the sky. You can go back in time, forward in time. You can look up the conjunction that's about to happen, or even simulate the eclipses. You can change your location on those apps. The one on your computer is much more powerful, and I use it all the time when I'm planning things for our planetarium. I'll use Stellarium before I go in our planetarium. Of course, we use the planetarium to see these things too, but sometimes we pre-plan with Stellarium. So that's a great tool. And also NASA, you can of course go to NASA, and they have Eyes on the Sky. If you look that up, that's a great there's great software, and some of it's browser based. You can go on and you can follow spacecraft and celestial events.
Fair warning with Stellarium, because I'm not sure if it was you or our mutual friend Derek Demeter who told me about it, but I lost hours of my day by playing around with Stellarium because it is so cool. You get to see all these different things. So unless you are Seth Mayo, who is doing very important work at the planetarium and bringing us up to speed on what's happening in the night sky. Seth, thank you so much for joining us.
My pleasure. Appreciate being on.
That was Seth Mayo, Curator of Science and Director of the Lohmann Planetarium in Daytona Beach. Still to come, how a soon-to-launch telescope could change what we know about the universe.
I think what Roman learns about what dark energy is going to be very exciting, because it could end up having us to rewrite the textbooks about what dark energy is.
The Roman Space Telescope and how it's exploring the unexplored. That's ahead on Are We There Yet? You're listening to Are We There Yet? From Central Florida Public Media. I'm Brendan Byrne. A new telescope is launching to study some of the biggest mysteries in space. Once in place, the Roman Space Telescope will answer questions like, what is dark energy and dark matter? What other planets are out there? And could there be planets like Earth in other star systems? But to do all of that and start its observations and explorations, it has to launch successfully and get to where it's supposed to be in space. NASA's Jeremy Perkins is Roman Space Telescope's integration and test scientist, and he joins us now to talk about those critical first steps of deployment. Jeremy, welcome to Are We There Yet?
Thank you.
Very exciting moment, just days away from launch, the telescope and the spacecraft fueled, undergoing final preparations. Let's talk about launch day. What happens on launch day, and what are you most excited about?
So on launch day, it starts really early for most of the engineers. They have to report on shift by about 3 a.m. for the 7 a.m. launch. And so that's just make sure everything is ready and they're checking out the spacecraft and making sure that everything is good to go with the environment and with the electronics. And then that gears up for the 7:20 a.m. launch to the Lagrange point 2, which is about 1 million miles from Earth. The launch is going to be incredible because it's a Falcon Heavy, so we get to see the launch go off, and then we get to see both side boosters return, which is also very, very impressive.
Yeah, seeing two rocket parts fall out of the sky is always a very cool thing. Controlled, of course. So, mentioned Falcon Heavy, right? Those two side boosters. There's also a center booster. 3 boosters, 27 engines on Falcon Heavy. That's because this thing is quite big and it's going quite far. You mentioned it's going to Lagrange point 2. Tell me a bit about its journey there and why you're going to that specific place 1 million miles from Earth.
It takes us a good 3+ months to get out there, and we're spending that time checking everything out and doing a whole bunch of calibrations and making sure everything is working the way we know it can. It's basically like our time to kick the tires and just make sure that the focus is right, the pointing is right. We do a lot of staring at the sky to get our first measurements of the sky. The reason we're going that far to L2 is there's multiple reasons. One is it means we're never blocked by the Earth, so that when we're looking at the sky, we have really good sky coverage of pretty much everything we want to see. The only constraint we really have is making sure the sun is on our solar panel side. Another really good reason to be out there is it's a very stable, mainly stable thermally. If you're going around the Earth, you're constantly going in and out of the sun. And so your whole observatory is heating and cooling and heating and cooling. And as it does that, it expands and contracts and expands and contracts. And one of the key parts of Roman is its stability. One way we can make sure it's stable is by reducing that breathing and that motion. And so being out at L2, you're basically at a temperature you're going to be at for the 5+ years that we're going to be out there.
Is Roman just getting there? Are you almost like a quarterback here on Earth and you are just launching it in one particular place and you hope it lands there? Or is Roman going to have some control in that 3-month journey while it goes?
Yeah, so we do have control. So the first big part of control is launch. So SpaceX will make sure they're sending us in as precise a direction as possible. They're also making sure our solar panels are pointed at the sun as they do so. But as soon as we get let go from the rocket, Roman powers up and we start Roman itself starts actively controlling itself. And so it has sensors that can tell where the sun is. And so its first job is to make sure that we're pointing our solar panels directly at the sun. And then there's several automated things that happen, especially in that first 24 hours. We have side solar panels that deploy and some other things that deploy. But then eventually we start talking to it and commanding it and interacting with it as we get out to L2. And so there's a little bit of sitting and waiting and watching, but then there's a lot of work on the ground by system engineers and discipline engineers and a whole bunch of people monitoring the data that's coming back and telling Roman to do things and also waiting for automatic things to happen.
Jeremy, are there some nerve-wracking points in this deployment? Are there moments that you are thinking about after it launches that are keeping you up at night?
Nothing really is keeping me up at night. It's more just general work that keeps me up at night right now,
Okay.
just preparing everything for it. There's some moments that are critical, but I wouldn't call them like keep me awake at night moments. Like we have the solar panels need to deploy, but we're going to have power even if they don't, because some of our panels are stationary. We have a high gain antenna that has to deploy. And so Roman has one of the key aspects of Roman is our data set is very large. We take about a terabyte of images a day and have to get that data back from L2 all the way to the ground. And so we have a high gain antenna, which is about as big around as I am tall. And so I'm about 6 feet tall. So it's a pretty big dish. And that's folded up underneath the bottom, and that has to deploy out. And then we have a cover over the main telescope that acts as a protective cover plus a sun shield, and that needs to deploy.
So you're sleeping easy when you get a chance to sleep, is what you're saying.
Trying to, yeah.
When do you breathe that sigh of relief? Is it when Roman makes those first observations?
One of the things I'm really excited about is the first light that hits the detectors. Like when we open that deployment and we get the instrument turned on and we have starlight hit the camera for the first time, that's going to be an amazing point during commissioning. And those images are probably not going to be the best images because they're first ones we take, but they're going to be one of the ones I remember probably for the rest of my life. But even then, there's the next challenge that's going to happen. We don't stop working until we get out there on orbit and start doing regular science operations. And so there's even after that, there's like little things that we've been worrying about and planning for throughout the life of this mission. And now we get to actually test out if what we built is working the way we think it will.
You're listening to Are We There Yet? The radio show exploring space exploration. I'm Brendan Byrne. We're speaking with NASA's Jeremy Perkins, Roman Space Telescope integration and test scientist. I would assume that you've got some observations already on the schedule for this. How far out are you looking at? And how do scientists get their hands on pointing this thing where they want it to go?
Yeah, so Roman is unique. It's not like some of the past pointed, like really narrow field missions that have been going on. So Roman's a survey mission. And so our power is in taking surveys of the sky. And so you can think about it like in the first month or so, or at a month during the first year, we're going to do a survey of the Milky Way. And this is a survey that would take Hubble basically 100 years to do. And so the real power is thinking about how to make these surveys useful to the broadest part of the scientific community as possible. And so there's been a lot of work, including having people write white papers and develop ideas to not only do the surveys that Roman was designed to do, but also think about how the community wants to use Roman. And the other part of that is the data that we take with Roman gets released to the public as soon as it's processed through our pipeline. So we're talking within like 24 hours so that anybody can go and look at what we just looked at with Roman. And so there's definitely input that folks can have in the process, and it's been designed from the ground up to like modify our plans and to add things as we go. But it's not like, please go look at this specific star. Most scientists are going to be, I'm interested in this type of object. Let me go see what's in Roman's data set with that type of object. So like if I'm interested in following a gamma ray burst, let me go find all the gamma ray bursts that have gone off since Roman has been up there for 5, 10, whatever years, and look at that data, and that data will be freely available.
Oh, that's really cool. That is super cool. Yeah. So you don't have to, try to get scientists like yourself to approve time on the telescope. It's looking at the whole sky.
Pretty much. I mean, we can't look at the whole sky, but we look at a big representative part of the sky.
Jeremy, you mentioned that Roman is able to take this sky survey in what would take Hubble 100 years. What gives it that capability? Yeah,
so one I already mentioned was the stability. So Roman's really good at taking a picture, moving, settling really fast, and taking another picture. And we basically do that over and over and over again throughout the lifetime of the mission. We have a field of view that's about 100 times the size of Hubble. So at the same sensitivity of Hubble. So in one picture, we can get the same sensitivity over 100 times the area of the sky that Hubble could in its field of view. It's the combination of that plus the very stable platform that gives us the ability to do those surveys, because we've designed this thing from the ground up. So when you're thinking about things on the telescope that could caused jitter. We've really beat that down and tried to make things very stable. So like the attitude control system that points us is really, really good at doing that and make sure that you're not shaking at all when you come to rest. So we can basically stop on a dime. So we take a picture, move, stop, take a picture, move, stop, and do that over and over and over and over again.
That stability gives you the clarity to see what you're looking for, right?
Precisely. Yep.
What are you looking for, Jeremy? What will you find with this telescope?
Roman is really designed for three specific things. It's designed to try to understand what dark matter is. And basically this is what's driving like the structure of the universe. That's what that pulls things together, is trying to understand dark energy. This is the force that pushes things apart. And then we're also trying to find and do a catalog of planets around other star systems in our galaxy and fill in that census. So those are like the three core things that we're trying to do with Roman, that Roman was designed to do. And then for me personally, what I'm really excited about is when you have a data set that's a terabyte of data a day, and you're looking at the sky over and over and over again, and you're scanning the sky, it's all the things that we are not expecting to see. It's all these 1 in a million things that we're going to be able to see with Roman that really excites me. And not any one person can go and like look at every object in Roman's database. The way I like to think about it is like Roman's database at the end of its prime mission after 5 years is going to be bigger than kind of your standard music streaming platform. And so there's no way like I could dig into that and find new music without the tools and the algorithms that these streaming platforms give me to like, have you thought of this? So there's scientists all over the world and in the country that are looking for very specific things in our data and developing the tools to like go find supernova and go find all of the galaxies that fit a very specific category so we can understand how they're clustered together and try to understand how dark matter and dark energy cause that clustering to happen. But it's the people out there that are like, oh, could Roman see tidal disruption events? Could we see stars getting eaten by black holes, and going and trying to find those in our data? And then the people that are going to find things that I haven't even thought about. That's what really is exciting me about the Roman data going forward.
That analogy to music streaming platform is absolutely bonkers, but it makes sense because a terabyte of data a day coming down. That is absolutely
it's like a million
wild.
songs being streamed down like from a million miles away, like every day.
Yeah, that's a lot to listen to.
I did a calculation. It's something like if I lived to 78 years old, which is kind of the average lifespan in the US, it's like 35 songs a day that I would have to listen to. And I would have had to start like when I was born at that rate to listen to a million songs.
That's wild. That is wild. Finally, Jeremy, you mentioned all these different scientists are developing different ways to use this and go through all this data. But I'm wondering for you personally, what is the one unanswered question that you hope Roman will help find the answer to?
I want to go back to like the dark energy question. I think we really don't understand what this is. And we have ideas about how it works, but then every time we've built something new to investigate it, or we've dug into the data further, it's behaving slightly different than we thought previously. I think what Roman learns about what dark energy is going to be very exciting, because it could end up having us to rewrite the textbooks about what dark energy is.
Jeremy, thank you so much for joining us.
No, you're very welcome. Thank you.
That was NASA's Jeremy Perkins, Roman Space Telescope Integration and Test Scientist. That's going to do it for this week's show. If you're not already, be sure to subscribe to the show's podcast feed so you never miss an episode. Do that on Apple Podcasts, Spotify, really wherever you get your podcasts at. Stay connected with this show. We're on social media. Instagram and Facebook handle is @AWTYSpace. If you got an idea for a future episode of this show, or you think you might make a good guest, well, reach out to us. Our email is arewethereyet@cfpublic.org. Are We There Yet is a production of Central Florida Public Media. Our producer is Marion Summerall. Editorial guidance comes from LaToya Dennis. Support for Are We There Yet comes from our listeners. Until next week, I'm Brendan Byrne. Thanks for listening.